Imagine floating in the darkness, stars glittering around you, and nothing. No explosions, no engine roars, just silence. Or is it? In this video, we're exploring the cosmic question. Is space completely silent? The answer is more complex and fascinating than you might think. To understand space's silence, we first need to understand what sound is. Sound is a mechanical wave. It needs a medium to travel. That means it moves through solids, liquids, or gases by vibrating molecules. On Earth, sound travels through air, which is why we can hear music, voices, and even traffic noise. But here's the key. No medium equals no sound. And that's the problem in space. Space is a vacuum. That means it's almost entirely empty. No air, no water, no molecules bouncing around like here on Earth. Without these particles, sound has nothing to travel through. If you were floating outside a spacecraft and someone screamed right next to you, you wouldn't hear a thing. Not because they didn't scream, but because the sound waves can't reach your ears. There's nothing to carry them. That's why, in spacewalks, astronauts use radios inside their helmets to communicate. Sound waves can't travel through the vacuum, but radio waves can. So is that it? Total silence? Not exactly. Space may be silent to our ears, but it's not devoid of activity. The cosmos is filled with motion. Stars explode, planets collide, solar winds howl across space. But none of it produces sound we can hear, because sound can't move through a vacuum. But here's where science gets clever. Even though we can't hear space directly, we can measure invisible signals, like plasma waves, radio waves, and magnetic vibrations, and convert them into audio we can hear. This process is called sonification. When NASA wants to listen to space, they don't use microphones. They use sensors that detect electromagnetic data. Then, they translate that data into frequencies we can hear. The result? Eerie, beautiful, and sometimes haunting space sound. You've probably heard these sounds online. The chorus of Jupiter, the humming of the sun, the screeching of solar flares. They're not actual sounds in space, but data converted into audio allowing us to hear the invisible. So, while space doesn't carry sound in the traditional sense, it's not as silent as we thought. But the moment they step outside into open space, pure silence, unless they touch something. In fact, astronauts have reported hearing sounds like faint knocks or buzzes, caused by vibrations traveling through their suits or equipment. That's because solids can still transmit vibrations, even in space. So astronauts don't hear space itself. They hear tools contacting their bodies or helmets. It's not exactly silent, but it's nothing like Earth. So is space completely silent? Not exactly. In terms of traditional sound, yes, it's silent. But using technology and clever physics, we've found a way to hear the universe. While the vacuum of space prevents traditional sound transmission, there are regions in the universe where sound can, and does, travel. How? Because not all of the space is a perfect vacuum. Certain parts of the cosmos are dense enough to carry sound waves. Let's take a closer look at these cosmic exceptions, nebulae and gas clouds. Nebulae are massive clouds of gas and dust, remnants of dead or dying stars. These clouds can stretch across light years and, though extremely thin compared to Earth's atmosphere, they still contain enough particles to transmit sound, albeit at very low frequencies. Astronomers have discovered sound waves rippling through these clouds. They're just so low in frequency, they can take years, even millions of years, to complete a single cycle. Planetary atmospheres. Let's not forget about planets and moons. Mars, for instance, has an atmosphere, much thinner than Earth's, but thick enough for sound to exist. In 2021, NASA's Perseverance rover recorded audio on Mars for the first time. The sound of Martian wind, even the zap of the rover's laser tool. But there's a twist. Sound travels differently there. Because of the thin atmosphere and its carbon dioxide-rich composition, high-pitched sounds fade quickly. You might hear a low thud or a murmur, but not the full range of frequencies like you do on Earth. Black hole surroundings. Black holes themselves don't emit sound, but the material swirling around them, in what's called an accretion disk, is hot, dense, and chaotic. These conditions can generate pressure waves that ripple through surrounding gases. In 2003, NASA discovered a sound wave from a black hole in the Perseus galaxy cluster. A B-flat note, 57 octaves below middle C, far too low for humans to hear, but astonishingly real. Narrator. These regions prove that space isn't completely silent. It's just selective about where sound can live. Coming up next, what does a black hole collision sound like? What are the loudest events in the cosmos? You won't believe the volume of the universe's most extreme moments. Let's dive into the most extreme and the loudest events in the universe. Black hole collisions. When black holes collide, the universe trembles. These aren't just dramatic. They produce immense gravitational waves. In 2015, the LIGO Observatory detected such a collision. The resulting signal was brief, lasting only fractions of a second, but the energy it released was staggering. More than all the light from all the stars in the observable universe combined at that moment. Although these waves aren't sound, they can be converted to sound through sonification. And when you listen to it, it's like a cosmic chirp, a deep warbling tone rising in pitch before abruptly ending. Supernova. The explosive deaths of stars. Supernovae are among the loudest natural events in the cosmos. When a massive star dies, it collapses and explodes in a burst of light, heat, radiation, and pressure waves. These pressure waves can move through surrounding gas clouds and, in theory, could be considered sound in that medium, but we'd never hear it naturally. The explosion's energy would vaporize anything nearby, and the waves travel in such thin gases that a single oscillation might take years. NASA has taken X-ray and radio data from supernova remnants and transformed them into haunting soundscapes. One famous example is the Cassiopeia supernova, which sounds like a slow, ghostly choir. Quasars and pulsars, cosmic beacons. Quasars are distant galaxies with incredibly bright and active centers, powered by supermassive black holes. As material falls in, it heats up and emits powerful jets and radiation. Then there are pulsars, rotating neutron stars emitting beams of electromagnetic radiation. They pulse at incredibly regular intervals, some dozens of times per second. When sonified, they create eerie, rhythmic ticking, like the heartbeat of the universe. Narrator. These cosmic events show us a universe brimming with energy and rhythm. Not silent, but pulsing with frequencies we can now interpret and hear. Coming next, how NASA turns these signals into sound. Discover the science behind sonification and how we're finally able to listen to the cosmos. The universe doesn't produce sound the way Earth does. Instead, it speaks in energy, light, radiation, and gravitational waves. But what if we could listen to it? That's where sonification comes in, the process of turning space data into sound. Let's simplify this. NASA's telescopes, like Chandra, Hubble, and James Webb, capture invisible waves, X-rays, infrared light, gamma rays. These waves don't make sound on their own, but all waves have one thing in common: frequency. So, scientists map these frequencies to sound. Brightness might become loudness, energy turns into pitch, distance becomes timing. This lets us convert images and radiation from space into immersive audio experiences. Example 1. The Milky Way's center. In 2020, NASA created a stunning sonification of the Milky Way's core. Using X-ray, optical, and infrared data, they translated stars, dust, and black holes into eerie, rising tones that sweep left to right across the image. Example 2. The Pillars of Creation. This famous Hubble image was turned into sound too. Bright stars became high-pitched notes, while gas and dust gave off soft, ambient hums, almost like music from another dimension. Example 3. Gravitational waves. In 2015, when LIGO detected gravitational waves from colliding black holes, that ripple was also turned into sound, a brief, rising chirp. It lasted less than a second but spoke volumes about the power of the cosmos. These sonifications are more than cool effects. They help scientists interpret complex data and even allow people with visual impairments to see space through sound. It also gives us something more: connection. When we hear the sounds of the universe, it no longer feels distant. It becomes a living, breathing thing, full of motion and rhythm. So, is space silent? Not if you know how to listen. Up next, what happens if you scream in space? Can astronauts hear anything? And how do spacesuits help us reclaim sound in the silence? So, what if you screamed in space? Would anyone hear you? The short answer: no. Why? Because space is a vacuum. There's no air to carry sound waves. Your voice, your scream, your favorite song, it all depends on molecules bumping into each other. Without a medium, sound simply doesn't travel. But here's where things get interesting. Inside a spacecraft or suit, sound is alive. Astronauts aboard the International Space Station talk, laugh, play music, all like they would on Earth. That's because the station has a pressurized atmosphere. Air inside allows sound waves to move, just like on Earth. Same goes for spacesuits. They're equipped with internal air and built-in communication systems. When astronauts talk to each other during spacewalks, their voices are carried not through space, but via radio signals. So how do astronauts communicate outside the craft? They use radio communication. Their microphones convert their voice into radio waves, which are transmitted wirelessly. These waves don't need air. They travel through space just fine. Then the receiver inside another astronaut's helmet turns those waves back into sound. So even in space's silence, two astronauts can talk like they're on a phone call. Now imagine watching a spacewalk without that system. One astronaut waves, mouths something, but complete silence follows. It's eerie. Without a medium or radio, you'd never know they spoke at all. Other sounds astronauts hear. Inside the spacecraft, astronauts are surrounded by noise, humming fans, buzzing electronics, pumps, and airflow systems. Space isn't silent to them. In fact, NASA has to monitor sound levels carefully to protect hearing over long missions. Sound travels through solids too. Here's something cool. In space, sound can travel through solids. If two astronauts touch helmets, sound can pass from one to the other through the helmet material. Kind of like putting your ear against a wall to hear what's on the other side. So while screaming into space is pointless, smart engineering ensures astronauts are never really cut off from sound. In fact, space missions are filled with it, just not in the way we hear it here on Earth. Coming up next, could we use sound for space exploration? What might future missions reveal through vibrations and audio mapping? What role will sound play in the future of space exploration? We often think of visuals when it comes to space, telescopes, images, and animations. But sound, too, is becoming a powerful tool in understanding the universe. Let's explore how. Sonification, the rise of audio data. NASA and other space agencies are pushing the boundaries of sonification, turning data into sound. It helps scientists identify patterns that are hard to spot visually. For example, a sudden spike in X-rays might be heard as a high-pitched tone. A gravitational wave ripple could sound like a drumbeat. These sounds let researchers hear changes across time, sometimes making it easier to detect anomalies. And here's a bonus. Sonification makes space science more accessible to the visually impaired. It allows everyone to experience space. Audio sensors on future missions. Future missions may rely more on audio sensors. Imagine placing sound detectors on Mars, Europa, or Titan, not just to hear alien winds or storms, but to detect subtle changes in the environment. Cracks in ice layers, gas bubbling beneath the surface, tiny meteorite impacts on distant moons. Sound can reveal shifts long before cameras can catch them. Artificial intelligence and sound. AI is being trained to analyze audio data from space. One future possibility? AI systems aboard spacecraft that monitor all onboard sounds, engine hums, fan rhythms, and air circulation. A change in frequency could signal a failing system before disaster strikes, like a space-age mechanic that listens constantly. Public engagement through sound. Sound makes space more relatable. Listening to the sonified center of the Milky Way or the heartbeat of a pulsar turns abstract science into something you can feel. Agencies now release sound-based space content, cosmic concerts, black hole sonatas, and Martian wind recordings to spark curiosity and connect audiences worldwide. So the future of sound in space isn't about hearing space the old-fashioned way, it's about interpreting it. Through technology, creativity, and innovation, we are transforming the silent universe into something we can actually listen to and understand better than ever before. In the silence of space, we're learning to listen, not with ears, but with imagination, technology, and science. For centuries, we looked to the stars and imagined only silence, a cold, empty void. But today, we know better. Through science, imagination, and sound, we've discovered a universe that vibrates, not with spoken words, but with waves of energy, pulses of light, and ripples in time. From supernova to black holes, Mars to the Milky Way, we've learned that sound doesn't need air to exist, only a medium, a message, and a mind willing to listen. A black hole can sing a note 57 octaves below middle C. A pulsar ticks like the heartbeat of the cosmos. A Martian breeze hums gently through an alien sky. Each frequency is a whisper of cosmic truth, and we're just getting started. As technology evolves, so does our ability to translate the universe into music, turning invisible forces into melodies we can understand. Scientists, engineers, and artists are now collaborating to compose a soundtrack of space. These are not just sounds, they are stories, waiting to be heard. So, is space truly silent? No, it is full of echoes of creation, destruction, rhythm, and mystery. We just needed the right tools and the right curiosity to listen, because in the vast, seemingly silent universe, we've found something truly extraordinary. A cosmic symphony, playing just for those who dare to hear. Keep listening.